Okay, we are looking at similar figures, and this is 10-7 from our textbook. And our learning target today is I can determine whether figures are similar and find a missing length in a pair of similar figures. Okay, vocab in this lesson that we'll be going through, similar figures, corresponding angles, corresponding sides, and indirect measure. So we will go through all of these during this video. So figures that have the same shape but not necessarily the same size are similar figures. Okay, so we have these two triangles here, and they are similar. They make the same shape, but as you can see, they're different sizes. And so we would write it like this. Okay, it says triangle. That little symbol means triangle. RST, so we have point R, ST, each of the vertexes in our triangle, is similar, that's what that little wave means, is similar to triangle XYZ. And if you notice, they go in the same order. So the R matches up with the X, S matches up with the Y, T matches up with the Z, same in the order of these. Okay? And if you look down below here, the matching sides are S and T and Y and Z. So on this triangle, it's the green sides. They match up. S and R, Y and X, those are the red sides. And then R and T and X and Z, those are our blue sides. So the sides of similar figures that match are called corresponding sides. Okay, they're corresponding, they match up with each other. They're the same sides of the triangle, but different sizes. And then the same thing for angles. So the matching angles are angle S and Y. Okay, again, I was saying that how they match up. R and X, and then T and Z. So the angles of the similar figures that match are called corresponding angles. Okay, so that's what our sides and angles are. Okay, some stuff to write down here. So if two figures are similar, then this means two things. The corresponding sides are proportional. Okay, so they are the same amount of difference between them. We'll go through that in a second. And the corresponding angles are congruent. So the angles are equal to each other. Okay, they have a picture here where they show that the angle A and D are the same length, B and E are the same, C and F are the same. Okay, and then they have it in symbols. They're showing you triangle ABC is similar to triangle DEF, and you can see they're telling you what that symbol means. And you can look at the corresponding sides, okay, and the corresponding angles. And then something to note over here, some symbols you should write down. The one squiggle means that they are similar. If it has an equal sign with the squiggle, it means that they are congruent. All right, so we are looking at identifying similar figures. Which trapezoid is below is similar to trapezoid DEFG? So we have this one up here, and we want to figure out which one below is similar. Okay, so the way we do that is we find the ratios of the corresponding sides to see if they are constant. So this side EF matches up with the side QR, XY, and KL. Okay? And then the side GF, do a different color, GF matches up with SR, XY, ML. And so down here, they're comparing each of these trapezoids and the sides. So they're comparing 4, 6. Okay, that's the side of EF compared to QR, which is 2/3. And then we have to compare it to the other ratio, GF to SR, which is 12/14, which simplifies to 6/7. So therefore they are not similar because these two ratios are not the same. Okay, EF now is 4 compared to 3. And then for FG compared to YZ, that's 12/9, which is 4/3. Okay, so when they're simplified down, they have the same ratio, so therefore those two shapes are similar. And then we can look at this last triangle, JKLM. EF and KL is 4/5. FG and LM is 12/10, which is 6/5. They are not the same, these two, so therefore they're not similar figures. So what you're trying to do is you're trying to find those proportions that are, the ratios that are the same. Okay, so we can come to this conclusion here that this trapezoid and this trapezoid are the same. Okay, so let's try one on our own here. Which triangle below is similar to triangle DEF? Okay, well, let's start DEF to, so triangle DEF compared to XYZ. Okay, so the side DF over, now D corresponds with X, F corresponds with Y. So that side goes with that side. So they have a, so DF is XY, and they have a ratio of 6/8, which simplifies down to 3/4. Okay, now let's compare FE to YZ, and that would be 15/20, which divide the top and bottom by 5, and that's going to be 3/4. So we find that those two triangles are similar because the two, they have the corresponding ratios. Okay, they are the same. And you could go through and compare 6/4 and 15/12 and see. Let's do that. So 6/4, divide each of them by 2, you would have 3/2. And since we did the 6 first, we have to do the 15 on the top, so 15/12. You can divide them each by 3, so you would have 5/4. Those are not the same, so they are not similar. Then you would have 6 and 3, which is 2/1. And then 15/6. So again, we're just comparing sides that are corresponding to each other. Divide by 3, that would be 5/2. Nope, those are not the same. So our conclusion is that those two are similar. And we would write the statement, triangle DFE is similar, again similar is that one squiggle, to triangle XYZ. And again, you have to make sure D and X, F, Y, E, Z, those corners match up with each other. Okay, so now we are looking at if we had similar figures and we have a missing side that we want to find. So if triangle RST is similar to triangle XYZ, so that tells us that the vertice R matches up with X, S with Y, T with Z. They go in the same order. So we're trying to find the length of XY. So we're trying to find this side here. Okay, so since the two triangles are similar, the ratios of their corresponding sides are equal. Okay, so we have to write and solve in a proportion. So what that is saying, like we did on the last slide where we found those ratios and they were the same, that's what we're looking for here. So first what we have to do is we have to write a proportion. So I'm going to move this down. We're going to work up above so I have enough room. Okay, so first we have to write the proportion. All right, we are going to compare, I'm just going to pick corresponding sides. I'm going to pick this side and this side. They correspond to each other. So we have RT matches up with XZ. Okay, and then RS, since we are looking for XY, we need to pick the side that matches with that, which is RS over XY. Okay? So now we fill in with the numbers that we have. So RT is 6 meters. XZ, according to our pictures, 18 meters. RS is 4 meters. And XY is what we're looking for. So that's where we put our variable in. So I'm going to fill it in with an X. Okay, find the cross products. Okay. Again, cross, that means to cross multiply. Okay. So 18, so we have 6 times X equals 18 times 4. So we have 6X. 18 times 4 is 72. Solve for X to get rid of it. Since it's multiplication, we do the opposite, which is division. So divide each side by 6. So X equals 12. So that means XY, put the line over the top, that means that side is equal to 12 meters. Okay, so to solve it, you just pick corresponding sides, set up a proportion, and then solve. Okay, here's one for us to try. If triangle ABC is similar to EFG, find the length of AC. So let's set up our proportion first. Okay, so we are looking for AC, and that corresponds, well, C matches up with D. So let's see, because if you notice, this one they're trying to trick us a little bit. They have the triangles in different corners, or turned on different sides. So C matches with D. I'm going to color code these to help us out. A is equal to E, and B equals F. And I was just noting that by matching up the letters in the order of our statement here. Okay? All right, so AC matches with ED. Okay. Let's see, so I'm going to use, on the triangle that we have a side on, I'm going to use AB, which matches up with, looks like, EF. Okay, so those are the sides we're using. Now let's fill in the numbers that we have. AC is what we're looking for, so that's our variable. ED is 3 feet. AB is 28 feet. And EF, I don't really need to include the feet part. Sorry, EF is 4 feet. Okay. Do your cross multiplication. We get 4x, 4 times x equals 3 times 28. I want you to write out each of these steps because I think some of us are forgetting these. Okay, so we have 4x equals 3 times 28 is 84. I'm going to carry this up above, so 4x equals 84. Divide each side by 4. The 4's cancel, so x equals 84 divided by 4 equals 21. So the length of AC equals 21 feet. And if you think about it, it makes sense because this triangle here is smaller, and so it should be somewhere in with that set of numbers. Okay, so that's how you solve for missing lengths. Set up proportions of sides that are corresponding to each other, and then solve it. Okay, another vocab word that you should write down is indirect measurement, which uses similar figures to find the length, width, or height of objects that are too difficult to measure directly. Okay, so our example here, Old Faithful in Yellowstone National Park shoots water 60 feet into the air that casts a shadow of 42 feet. What is the height of a nearby tree that casts a shadow of 63 feet? Assume the triangles are similar. Okay? Excuse me. So we have these two triangles. We know the height of Old Faithful, but we want to know the height of this tree. So we're going to use the lengths of the shadows, okay, to solve our equation. Or to solve for the height of the tree. So I'm going to set up a proportion. I'm going to do the height of the objects over the shadows, okay? And we're going to compare the tree. So the height of the tree we don't know. The shadow of the tree is 63 feet, okay? Then on this other side, I'm going to do Old Faithful. So the height of Old Faithful is 60 feet, and its shadow is 42 feet. Do my cross multiplication. 42 times x equals 63 times 60. So we have 42x, 63 times 60, 3,780. Get rid of the 42, so we divide both sides by 42. So 3,780 divided by 42, x equals 90. So the height of the tree is 90 feet. So that's how we can solve using indirect measurement. Okay, so that is the notes for 10-7 with similar figures. Okay, the biggest thing is to remember to set up proportions with corresponding sides. Okay, the sides that are similar to each other. Okay, so if you're still stuck, go back and rewatch any part that you need to. Otherwise, you can look in the textbook at the examples or the online tutor videos. Otherwise, head on over, take your 10-7 NICU at this time.